Now I'm under the impression that if the sketches look complicated, then the questions are actually easy. And then if the sketch look kind of plain, and then the questions might be hard. So let's see what's happening in this question here, right? So for 4.2.1, the question is saying that let's write down the y coordinate of C, right? So clearly we have two graphs here, f of x, which is x squared minus 4x minus 5, right? Which is the quadratic function you see on the graph. And then we have an exponential function, g of x, right? Which is a multiplied by 2 to the x plus q. And then e and h are the x-intercept. We have e here, as you can see, and then we have h here being the x-intercept. So this line here is actually our x-axis, and this line here is our y-axis, right? And then c is the y-intercept of f. So we have c here being the y-intercept of f, and it lies on the asymptote of g. Okay, c is the y-intercept and it lies on the asymptote of g. The two graphs intersect at d, so the intersecting here at d, the turning point of f. So the first question, the y coordinate of c. So c is the y-intercept of f, right? So if we're looking for the y-intercept, we always let x be equals to 0, right? So for that function f of x, if we do that, we're gonna get f of 0 being equals to 0 squared minus 4 multiplied by 0 minus 5, right? So it should be easy to see here that f of 0 is gonna be equals to minus 5, right? So the coordinate, the y coordinate of c is clearly minus 5, right? Because that's what we get when we let x be equals to 0. And then the next question, 4.2.2, let's determine the coordinates of d. D is the turning point of f of x, right? So we have f of x, let's not forget, being equals to x squared minus 4x minus 5, right? If we want to find the coordinates of the turning point, it's beneficial if we start with the x value of the turning point, right? Because we have a formula for that. We can say that x will be equals to minus b divided by 2a. So this will be equals to, so b is the coefficient of x, right? So that's supposed to be minus 4, and then a is the coefficient of x squared, so we're just gonna have 1 there. So now we can see that x at the turning point should be equals to 2, right? Now that we have that 2 there, we're just gonna substitute it in the equation f of x, right? F of 2 being equals to 2 squared minus 4 multiplied by 2 minus 5, right? So this will be equals to, so we have 4 minus 8 minus 5, and that should be equals to minus 9, right? So the coordinate of d, we have 2 for the x value and minus 9 for the y value, right? It's easy to see. Now let's do 4.2.3. So 4.2.3, we're looking for the values of a and q, right, from our graph g of x. So g of x is equals to a multiplied by 2 to the x plus q, right? Q is the asymptote of our graph, but we are told that the asymptote of g is at the y-intercept of f. So now we can easily say that q is equals to minus 5. So if q is equals to minus 5, then we have g of x being equals to a multiplied by 2 to the x minus 5, right? So now what we can do here, we can substitute the coordinate d so that we can find a, right? D has coordinates 2 and minus 9, because d lies on f of x and g of x, so we can substitute it in that equation. So if we substitute it, we shall get minus 9 is equals to a multiplied by 2 to the 2 minus 5, right? So minus 9 equals to 4a minus 5, right? So minus 4 is equals to 4a. So a is equals to minus 1, right? So we have determined the value of a, and we have determined the value of q, right? Let's do 4.2.4. So 4.2.4 is saying that let's write down the range of g, right? So we have g of x being equals to minus 2 to the x minus 5, and we're supposed to determine the range of the graph, right? We can just easily look at the sketch here, right? Because as you can see, the y values will never be greater than minus 5, right? They actually never touch there. The y value gets approximately, it gets infinitely closer to minus 5, but then it never really touches minus 5, right? But then going down, the y value goes to minus infinity, basically, right? So we're saying that the y value will always be less than minus 5, right? The y value is always going to be less than minus 5. So 4.2.5, determine the values of k for which the value of what? F of x minus k will always be positive, right? If we come to a graph f of x here, our turning point is here at d, where the y value is minus 9, right? So we know if we have f of x plus 3, then that moves the entire graph 3 units up, and then if we have f of x minus 3, then that moves the entire graph 3 units down, right? Then we have to shift it more than 9 units up, right? If we want our graph to always be positive, because if we shift it more than 9 units up, then it's going to be above the axis, so all the values will be positive, right? But here, the tricky thing is here, we have f of x minus k, right? So if k here is less than minus 9, then we will have shifted our graph enough units such that the entire function f of x is positive.